Okay, so there's going to be 4 types of transformations we need to look at. We've got translations, rotations, reflections, and enlargements. And with enlargements, you can do reduction as well. Okay, so first of all, we're going to look at number 1, translations. Okay, so for all these, they will take place on a gridded sheet. I don't have a gridded sheet here, but you have in your workbooks, so it should be a little bit easier for you. So translation is moving a shape. And we move the shape up, down, left, right. Okay, so you can move it in any of those directions. What do we use to move the shape? How do we write that? Well, we use something called a vector, which is this thing. Now the vector, this top number tells me left or right, and this bottom number tells me up or down. So what you see in a vector is often -2, 4. And I'm going to translate that. If it's negative, it'll be to the left, and if it's positive, it's to the right. So that is left 2 units. You got to move this left 2 units. So if I was moving this box, I would move it this way, 2 squares. Positive number here means up. A negative number means down. So that's up 4 units. So after I move this box 2 units left, I got to move it 4 units up using my boxes. Okay, so once I plotted that point, 2 units up, so that point, that's the bottom left corner of the box. I can probably just draw the rest of the box the same shape, the same size above. Okay, it's not quite the same size, I ran out of space, but you get the idea. So this is a vector. So if I have a vector 3 minus 1, that means right 3 and down 1. Okay, so this is called a vector. It shows the direction of a translation. So you got to move a shape. It might be a rectangle like I've drawn. It could be a point. You just move that point. And it could be like a triangle. And you'll be often asked to do a translation. That's what that vector means. Second, a reflection. All right, so a reflection would usually be a line, a mirror line. So if we have an XY axis like this, they might draw in a mirror line for you and ask you to reflect a shape. So this is a very sketch. So they might draw in a mirror line here. So there's our mirror line. This line would be, well, it goes through X at 2. So it's called X equals 2. We should remember that. And maybe they have a triangle over here. And they want you to reflect that triangle in the mirror line. Okay. Well, let's move a point. This point is 2 units away. So 2 units, so 1, 2. So its reflection must also be 2 units away on the other side, 1, 2. So that's that point's reflection. So you're just using the scale. So that you'll have boxes in yours. So this one is 3 units away. 1, 2, 3. So its reflection must be 3 units away. 1, 2, 3. So it's over here. So you should notice it's kind of backwards. It's not translated anymore. It reflected over. So if you want, you could use this as a fold line, and it has to be perfectly folded across it. So that means that this unit, I know it should be here 4 units away. 1, 2, 3, 4 units away. 1, 2, 3, 4. So it's over here somewhere. So does it fold perfectly across that line? Yes. So that is a reflection using a mirror line. So sometimes they can put these lines diagonally, which makes it a little bit trickier. For that, just do the distance of each point like I did, maybe use a ruler instead. So if it's diagonally, and we have a point here, get your ruler out, measure the distance perpendicular to the line, so a straight line. So what's that distance? It is 2 centimeters. Well, the point of its reflection must be 2 centimeters the other side as well. So just use a ruler for that. So reflection. So you should have done all these before. This is just revision. Okay. Oh, and when you are doing reflection, should I say, they may give points, A, B, C, something like that. When it's reflected, it's called A dash, B dash, a little dash, just to say it's not the original anymore. This is the object, it's called, and when it's in a new place, it's called the image. So it's an image of the object, so it's a reflection of the object. And it's the same for translations. If you've moved it, transformed it in any way, its new thing is called the image. All right, rotations. Okay, so rotations generally not really asked because sometimes you need see-through or tracing paper to do them. You can just use any A4 page. If you can see through it, it's fine. If you want to rotate a shape, so let's say we have a triangle like this, and when I want to rotate it, it'll give you the number of degrees, so maybe it'll say 270 degrees. It'll give you the center of the rotation, so they might say the origin or 0, 0. And then they will say the direction. So I'll give you 3 bits of information. So for this one, we're going to go anti-clockwise. So you can either go clockwise or anti-clockwise. Let's translate to see what that means. 270 degrees. Okay, so we know they'll only do 90, 180, 270. They won't do 360, and we'll see in a second. So there's only 3 options. So the degree can be 90, 180, and 270. Most often asked is 90 or 270. Center is almost always the origin, so 0, 0 is used. So that'll be just the point at which you put the pen in the sheet, and we'll look at that in a second. And the direction, there's only 2, clockwise and anti-clockwise. Of course, clockwise will be that direction, and anti-clockwise is the other direction. Okay. All right, so let's do this one. So what you do is just ask the examiner, if it's an exam, for a piece of paper to do this, so you can see through it. Just draw over it, like that. Okay, that's that done. What do I do? This is the center now. The center is 0, 0, and that's where I put my pen. So I'm putting my pen there, and I'm holding it there, and I will in a second rotate. And I want to go 270 degrees. So it says 270 degrees, and anti-clockwise. So that's this way. So let's look at that. So that's holding my pen, I turn the page. Boom, that's 90 degrees. That's a quarter turn. So notice my page only turned a quarter of the way. If I turn it one more, that's going to be 180 degrees. So it's actually a type of a reflection there, isn't it? In a diagonal line. And then I need to go 270. So I keep going, bring it another 90 degrees, and it is here. So it's moved to this quadrant. So what would I do then? Well, I'd lift up the page ever so slightly, and I'd start to draw in underneath what it looks like. And then I take my page away, and that is it, rotated. Should be the same looking shape, but of course mine is very sketchy. 270 degrees, it's gone anti-clockwise. It's about the origin. Okay, so we'll say about, that means that's the center. Okay, so that's how you do it. Just ask for a piece of paper. You can just use a normal A4 page. You can see through them fine. I'll give you some tracing paper if you're on campus at any stage. Last one then is enlargement. For this, it's generally just on a not on a coordinate diagram. It's just on a normal, just blank diagram. So, but with the lines on it, it'll give you a shape, and it'll give you. Oops. Okay, the battery's about to die, so I'll fly through this. And I'll give you a point, and I'll say enlarge this. So they might call the shape by its A, B, C, D, whatever it is, the corners of it. Width, center, C, so that point is C, the center, and a scale factor, which we looked at a little bit with similar triangles, didn't we? Scale factor of 3, or they could say the scale factor is k equal to 3 or something like that. But that means 3 times bigger. If it was half, it would mean half the size. So half as big. Now how do we do this? We get a ruler. So I'm actually going to use a ruler this time. We get a ruler, measure the distance of each point. So if I look at that, what's that distance? From the center to here. It's 3.6 centimeters. You don't need to write in, but you'll see why I do it in a second. So 3.6 centimeters. That means that point is 3.6 centimeters away from the center of the enlargement. Now its new point, its transformation must be 3 times bigger. So 3 times further from C. So what's 3 times 3.6? 10.8. So I do it 3 times further. So I just keep it on the same line. You should draw dotted lines, not a heavy line like I did, but get to 10.8 and put in a new point 10.8 centimeters away from C. So that's 3 times further away. You do that for all points. Let's do another point. This one's going to be slightly closer, I think. That's 3.2 centimeters away. So 3.2, 3 times further is going to be 9.6 centimeters away. So I'm just going to dotted line, draw through the original shape. Oops, that's slightly off. Through the original shape, and then on 9.6, wasn't it? 9.6 is about here. Okay. So what you see is going to happen if you did that for all shapes, and my battery's running out, so I'll just get through this nice and quickly. If you did that for all shapes, you'll see that this point is about there, and this point, measure the distance, and then go 3 times further. That'll be the furthest one, somewhere there. And when you join them, you'll get a square, or well, this is a rectangle, 3 times the distance from C, and it'll be 3 times bigger, hence an enlargement. Okay, and that is the 4 types of transformations that you can be given. So what I'm going to give you to do for the rest of the lesson, and I'll put it up and manage back, is on page 422 or 3. I'm going to give you some questions from those pages to have done for tomorrow. Not many. Just check it out, manage back. I'll be setting it as a homework and I'll send you an email in the next 2 minutes. Any questions?